cover this one. So I told you at the beginning, the benefit of using, the sine, cosine, or tan is just to get the missing side. If we have a missing side, if you have a missing angle, and you want to get it, so it makes sense. This one, it follows the Pythagoras theorem, because all of them, you could apply them in the right angle triangle. Is it right? So, but you have to remember that whenever we have something like this, let me try to draw an arbitrary triangle like this. So we have a right angle triangle, and you could identify that we have a right angle triangle, that we have a little square. You could figure out that we have a right angle triangle, right?
Yeah.
So whenever we have, angles, so the trigonometry function helps you to get the relation between the sides together. So, for example, if you have this one seems like 30, for example, right?
Mm-hmm.
So,
Yeah.
and I told you that this one, it seems like, for example, the hypotenuse, it's going to be 10. So you have the ability to get the opposite, or to get the every single side of it. So let me give you an example. So, but before doing it, let me tell you that the sine, it's going to be opposite over hypotenuse, and sometimes we call it a SOHCAHTOA. So this one seems like sine, it's going to be opposite over hypotenuse. So what if you have cosine? It's going to be adjacent over hypotenuse. So what about the tan? It's going to be sine over cosine, or sometimes we call it first over first, or numerator over the second numerator. So it's going to be opposite over adjacent. Did you get it?
Yeah.
So this one, it makes sense if we have something like this one. So we have sine 30. If I want to do it, so it's going to be sine 30. Sine 30, you could say that this one seems like opposite, I don't know it, so it's going to be x over hypotenuse. So it's going to be x over 10, right? So if you want to get the opposite, it's going to be pretty easy for me to get it. So this one, it needs you to multiply both of them together, because you have to use the cross multiplying. So it makes sense that's going to be x, it's going to be 10 multiplied by sine 30. And as you know, that sine 30 is going to be half. So this one, x is going to be 10 multiplied by half, which makes sense. This one's going to be 5 centimeters. So I figured out that this side is going to be 5 centimeters, right?
Yeah.
So it helps me to understand how is everything is going on whenever we have a right angle triangle, right? Did you get what I mean?
I get what I mean, but I have a simple question.
Yes, sure.
It has also the reverse sign, which is -1.
Yeah, you mean cosec.
Yeah. How can I identify the difference between both of them?
Yeah, but honestly, the basic trigonometric function, I'm talking about it right now, but after just a little bit of time, after realizing every single part of it, I'm talking about sine, cosine, and tan. I'm gonna illustrate to you how could you deal with the reciprocal of sine, cosine, and tan. I'm talking about cosec, sec, and cotan. But right now, I'm still illustrating to you how could you figure out every single part. But here we have this one, it seems like, for example, if we have this one, it seems like 3, 4, and he told me that I need to get the sine of C. But before doing it, I have to make sure that I have every single side of it, right? But unfortunately, we have a method. So the hypotenuse, I can't even find it. So I need to figure out how could I get the hypotenuse. So we have a right angle triangle. You could apply the Pythagoras theorem. Is that right?
Yeah.
So it's going to be from the last session. Could you tell me? AC power 2.
AC power 2 plus the the AB and the plus AC BC.
No, just wait, hold on. AC power 2, it's going to be AP power 2 plus PC power 2. You have to remember that the Pythagoras theorem tells us the square root of the hypotenuse equals the sum of the square of the two other sides. Is that correct? So let me try to apply it. So AC squared, it's going to be 3 power 2 plus
CB, which is 4 to the power 2.
Yeah, so AC power 2, it's going to be 9 plus
And
16. So 9 plus 16.
24.
Say it again.
24.
You mean 25?
Oh, 25. Okay.
Yeah. Okay, so let me try to take the square root of 25. So
Yeah.
AC, it's going to be 5 centimeters. So I got it. So this one seems like 5 centimeters. And right now he asked me to get the sign of C. So it's obviously clear whenever you want to get the sign. So you have to apply so it means that the opposite over the hypotenuse. So we have the opposite and we have the hypotenuse. So this one's supposed to be 3 out of 5. Did you get it? What if he asked me another thing? He asked me to get the cosine of cosine C. How could I do this one? Could you tell me?
For
Remember,
this,
so ka toa.
okay. So we have to write the formula for this one, yeah?
Yeah, so it's going to be adjacent over.
Opposite.
No, just wait. Ka.
Yeah.
Ka stands for cosine.
Hypotenuse.
Yeah. So adjacent, it means this one. Where is the adjacent?
The down part.
Yeah, it's going to be 4. Exactly. Where is the
Yeah.
hypotenuse?
5 centimeters.
Yeah, exactly. So I got it. So what about the tan? If I want to get the tan of C, so it's going to be opposite over.
So, 4. So it's going to be 3 over 5, over 4.
Yeah, exactly. So let me give you another example. What if you have something like this? So this one, you have to make sure that we have a right angle triangle. So this one is pretty clear that we have this part seems like 10 centimeter. And this one's going to be 8 centimeter. But I'm still confusing because we have a missing right over there. I need to get it firstly, right? So right now he asked me to find sine x, cosine x, tan x. And by the way, he wants me to get the sine of z, cosine z, tan z. So what is the first step?
To get the opposite side.
Yeah, perfect. So I need to get the missing.
The opposite side.
Yeah, so xy power 2.
Plus
No, it's going to be the hypotenuse minus.
The 8 centimeter.
Yeah, okay. So it's going to be xz power 2 minus. Minus zy power 2. Is that correct? So xy power 2, it's going to be, where can I find xy power 2 is going to be 10 power 2, right? You have to start with the longest side. I told you the last time that the hypotenuse is the longest side in the right angle triangle, right? So I have to start with that. So it's going to be 10 power 2.
10 power 2 minus 8 power 2.
Yeah, okay. Let me get the expansion. So this one's supposed to be 100 minus 64. Is that correct? Yeah, so xy power 2, it's going to be 36. So what should I do?
Get the square root of 36.
Which is going to be 6 centimeter. Yeah. So it's obviously clear. I tried to figure out every single part, every single side of it. So let me try to write it. So we have this part seems like 6 centimeter. I got it. Is it correct? I need to get the sine of x, cosine of x, and tan of x.
Yeah. Alas. No, the second thing that we will do is we get the missing side of z, which is
So let me try to write over there. Sine of x. Could you show me? Sine x.
6 centimeter.
Just wait. Could you tell me the rule? So it's gonna be opposite.
So it's gonna be opposite divided by adjacent side.
No, so remember, opposite over hypotenuse.
Hypotenuse. Okay.
So the opposite, it's gonna be 8, right?
Yeah.
Over hypotenuse.
10 centimeter.
Yeah, exactly. What about cosine x?
Cosine.
It's gonna be a, remember, ka.
Okay, so it's gonna be hypotenuse.
Adjacent firstly. Adjacent comes first.
Yeah, adjacent. Divided by hypotenuse.
Yeah, I know. So where is it? I mean the adjacent of x.
The adjacent is the 8 centimeter.
No, just wait. The 8 is opposite, not adjacent.
Wait. So the down part is not the adjacent?
No, it's opposite to it. I'm talking about x, by the way. I'm talking about x. This one seems like opposite. So you'll find it in front of the angle. So this is called opposite. You have to remember whenever we have something like this. So let me try to draw another one to be able to understand what I mean. So if we have x and this one seems like y and this one's going to be z. I'm talking about x right now. So I told you, I mean, the hypotenuse is the longest side in the right angle triangle. So it's obviously clear without doubt that we have this part. It seems like the hypotenuse, right? I don't need to do it. So it's gonna be, it seems like constant. This one's alongside, seems like hypotenuse, right?
Yeah.
But the adjacent and the opposite, it's not constant. It depends on however you want to figure out the value of x or the angle of x or the angle of z. So this one, if you want to get the sine of x, so this one is obviously clear that the opposite is going to be right over there, because this one seems like the side which is in front of it, right?
Yeah, I got it.
And this one, it seems like adjacent. So for example, if I'm gonna tell you what is the sine of x, so you could apply that the sine of x is gonna be opposite over hypotenuse. So it's gonna be the opposite. It would be, if I'm gonna call this one as a p c, for example. So it seems like abbreviation. I've used it to make it just a little bit easier. So this one, it seems like a over c. Did you get it?
Yeah, I got it.
Yeah, okay. What if I want to get the cosine of x? Try to do it by your own. Okay. So the cosine, it's going to be
the opposite side by the
no, wait. Hold on. Could you say it again?
The cosine.
You mean adjust? You mean adjacent? Yeah.
Yeah, adjacent divided
Where is the
by.
adjacent?
And it's gonna be the b.
Yeah, perfect. So it's gonna be p over c. Is that correct?
Yes.
You don't have to get confused whenever you want to get the tan, because it's gonna be, I mean, the first letter over the first letter. So it's gonna be a over b, right? Or you could say that it's gonna be opposite over adjacent. So opposite is gonna be a over b. Did you get it? Yeah, okay. Right now, let me try to get the second part. Right now, I want to do another thing. I want to get the value of z this time. So how could I get the sine z? it's going to be opposite
So
over.
it's gonna be opposite over and hypotenuse.
Yeah, okay. So what is the opposite?
Can you just give me a second? Let me put them in the room.
Yeah, okay.
I'm back.
Yeah, okay. Let me continue. You told me that sine of z is going to be opposite over hypotenuse, right?
Opposite, yeah.
So the opposite, it's going to be, could you tell me? B over?
B over A.
No, just wait. Over hypotenuse.
Hypotenuse. So B over C.
Yeah, exactly. So how could I get the cosine of z?
Cosine of Z. It's gonna be
It's going to be adjacent, right?
adjacent over the hypotenuse. So it's gonna be
Yeah.
A by
A over C. How could I get the tan?
tan. It's gonna be B and B over A.
Yeah, okay, just wait and try to take a look. So I think, I'm not quite sure if you have noticed that we have something that's really interesting.
Nice.
So let me try to highlight it.
Okay.
So can you see this part?
Yeah, A and C.
It is the same thing of this part.
That means it's the opposite side. So it's gonna be C over A.
So can you see this part?
Yeah.
I'm trying to string it together. So this one, it's obviously clear that whenever we are trying to work out on the same triangle, the sine of the two complementary, one of the two complementary angle equals the cosine of the other. I'm going to convince you why right now. So let me try to return back to this one. So let me try to do it again. So right now, I want you to do it by your own. And now it's your turn to tell me how could I get the sine of x?
Sine of X. Okay. So the first thing we will do is
Remember, opposite over hypotenuse.
yeah, it's gonna be 8 over 10.
Yeah, exactly. So what about the cosine of x?
It's gonna be 8 over 10.
No.
6 over 10. 6 over 10.
Yeah, exactly.
Just
what about, yeah, okay. What about the tan of it?
8 divided by 6.
Yeah. Is that clear for you?
Yeah, now it's clear.
Yeah, what if I'm gonna try to do, I mean, I want to get the same trigonometric function, but to the second part, I mean the second angle. So let me try to do it, because I've been asked to do it, and he asked me to get the sine of z, cosine of z, and tan of z. So let me try to do it. So we have sine of z, cosine of z, tan of z, right? So sine of z.
So the opposite of
Yeah.
the sine of z is 6 centimeter.
So it's gonna be 6 out of?
6 out of 10.
Yeah, exactly. Perfect.
And then the adjacent is gonna be 10.
No, just wait. 10 is hypotenuse.
Hypotenuse 8 over 10.
Yeah, okay. What about the tan?
6 by 8.
Yeah, exactly. So hold on. So this one, if you think about it, so you will find out that 8 over 10, the sine of x, it's going to be the same thing of cosine of z.
Yeah.
Did you get it?
Mm-hmm.
What about this part? 6 over 10, I mean cosine of x, it's going to be the same thing.
Yeah.
So is that clear for you?
It is clear. I have a small doubt.
So right now, and the tan of x is going to be the reciprocal of it. I'm trying to flip it. So it was 8 over 6, and right now tan of z is going to be 6 over 8.
Okay,
So exactly.
I have a small question.
Yeah,
Just
sure.
go up to the question that we just did.
Yeah, do you mean this one?
Yeah. For example, if they ask to get the sine of y, will they ask this type of question? The corner?
Yeah, but it seems like we have sine. You want to get the sine of 90, right?
Yeah.
This
So
one seems right.
I won't ask this type of questions in the book. Look.
The sine of 90, it seems like 1.
Mm.
No. But anyway, I'll do it for you. And the cosine of 90 is going to be 0. So right now, let me try to go to something else.
Mm-hmm.
Okay, so I really care about the 30 degree. I want to know how could I get the sine of 30, cosine of 30, tan of 30. But before doing it, let me try to tell you something. It's really interesting. So whenever you have a right angle triangles like this, and if I'm gonna tell you this part, it seems like 90. I told you that we have a right angle triangle at the beginning. So I tried to label it. I tried to write a little square to be able to identify that we are trying to deal with right angle triangle. So, and all of a sudden we have 30 degree. So, and he told me that this part seems like 12 centimeter. And I don't have any other thing. But let me try to remind you that we have something. It really helps you to understand how could I get the sine. But before doing it, it seems like a little confusing because I told you that you could apply the Pythagoras theorem we have whenever we have, whenever we have two sides, I'd be able to get the third. But unfortunately, we have only one side. So I'm still confusing. How could I get the other? But remember, whenever we have right 30, so we have something, or we could say that we have a theorem that tells us that the opposite to 30 equal half the hypotenuse. I'll say it again. So the opposite to the angle 30 equal half of the hypotenuse. So it makes sense. This part, it seems like the half of 12, so this part is going to be 6, right?
Yeah.
And I'm still confusing. How could I do this part? But how could I get this part? But you don't have to get confused, because if you want to get the sine of it, the sine of 30, you could apply opposite over hypotenuse. So it's going to be 6 divided by 12. Is it correct? Because opposite over hypotenuse, so it's going to be 6 divided by 12, which makes sense. This part's going to be half.
Yeah. Which one?
You get that?
Added.
Yeah. What if I'm going to try to do another thing? This one, it seems like we have a missing. I want to get the cosine, but unfortunately, I don't know how could I get this part. But let me remind you that we have, right angle triangle. We have two sides. I'll be able to get the third by applying the Pythagoras theorem, right? So if you want to get the BC, so BC square, it's gonna be the square of the hypotenuse minus the square of the other side. So it's gonna be AC square minus
AB square.
Yeah, okay. Let me try to apply it. So this one seems like 12 power 2 minus 6 power 2. Is it correct?
Which is
So it's going to be, this one seems like 144 minus 36, which is going to be 108. Let me try to take square root of 108. So this one seems like 6 root 3. Let me write it. Okay. I'm going to keep it as 6 root 3, and I'm going to tell you why right now. Okay.
Okay.
So could you tell me, Malak, how could I get the cosine of 30?
Cosine, so it's the adjacent, so 6 root 3.
Yeah, perfect. Over?
What, 12?
Over 12. That sounds great. So if we have, 6 divided by 12 is going to be half. So it's going to be root 3 over 2.
Yeah.
Is that clear for you?
Mm.
What if I'm gonna try to get the tan of 30? As you know, that tan of 30, it's gonna be opposite over
adjacent side. So it's 6 by 6 to the
6 divided by 6 root 3. Let me cancel each other out. It's being canceled. So we have 1 out of root 3. Did you get it?
Mm.
So is that clear for you?
Okay for me.
Yeah, okay. Let me try to give you another example. So actually, let me try to abstract it for you.
Mm-hmm.
So you need to keep it. Whenever we have sine 30, sine 30, tan 30, I think you've been asked to keep it from your teacher. Is that right?
Mm-hmm.
So sine 30 is going to be half, right?
Yeah.
What about cosine 30 is going to be root 3 over 2? As we get it. And tan 30 is going to be 1 over root 3. And it's really important to help you to understand how could I get the reciprocal of cosec, sec, cotan. So right now, let me try to go a little bit farther to something else. What if you have something else like this? And this one is obviously clear that we have x, y. I'm not quite sure is that right or not. So let me try to draw another one. Yeah, okay, this one seems right. So he told me this part seems like 10 centimeter, okay? And he told me that this angle is gonna be 60. And as you know that the angle of the triangle, you could add up to 180, right?
Yeah.
So this part, I mean, I'm talking about the vertex. I'm talking about the angle x. We have the angle x, the measure of angle x. It's going to be 60, but which means this part, it seems like 30. Because 60 plus 30, it's going to be 90. 90 plus 90 should be 180. Is that correct? As I told you, that whenever we have 30 in the right angle triangle, the opposite to 30, it's going to be half the hypotenuse.
Yeah.
So how could I get the length of xy?
X and Y.
Hypotenuse, it's going to be the half of hypotenuse, right? So half of 10.
It's 5.
Yeah, so it makes sense that this part's going to be 5. So Mala, so do we have a message?
Do we have?
Yeah, where is it?
Can you repeat again?
I'm asking you, do we have missing side?
Yeah, the
Where is it?
Z and Y.
Yeah, okay. Let me try to get it. So the y power 2, it's gonna be the square of the hypotenuse. You have to start with the hypotenuse because I told you that the hypotenuse is the greatest and the longest, right?
X and Z.
Power 2 minus
the X and Y.
Yeah, exactly. So this one seems like zy power 2. It's gonna be x z power 2. It's gonna be 10 power 2 minus 5 power 2. Right?
So you give me 100 and here 25. 100 minus 25.
Yeah, this one seems like 100 minus 25, which is to make sense. This part seems like 75. I need to get the square root of 75. Right?
Yeah. 75.
So this one seems like 5 root 3. Is that clear for you?
It is clear.
Right now, let me try to get the sine of 60. Cosine of 60, tan of 60. Remember, the sine opposite over
Sine is
opposite over hypotenuse, right? Remember, so ka toa.
Oh.
Did you get it? Okay, so sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Tan is going to be opposite over adjacent, right?
Yeah.
So right now I want to get the sine of 60.
Sine of 60, it's gonna be opposite divided by the hypotenuse. So the opposite side is 5 to the
Root 3
with
over.
when the sine
Where is
the
the hypotenuse?
10.
Yeah, exactly. Which makes sense. Let me try to make it simple, much more than this one. So it's going to be root 3 over 2. What about the cosine of 60?
Sine of 60, so it's gonna be adjacent by the hypotenuse. So it's 5 by 10.
Yeah, exactly. Which makes sense. This part seems like half, right?
Yeah.
What about
and 10,
it's
it's the opposite by the adjacent side. So the opposite side is 5 to the root 3. And opposite side, no, the adjacent side is 5 centimeter.
Let me try to cancel this one. So it's going to be root 3. So it's obviously clear that, let me try to, to write it over there. So I told you that the sine of 30, it's going to be half, right? So this time I want to get the cosine of 60, sine of 60, tan of 60. So I think you have noticed that this part seems like root 3 over 2, right? What about the cosine of 60? It's going to be half.
Okay.
What about the tan of it? So it's going to be root 3.
Okay.
Did you get it?
Yes.
So it seems like I'm trying to do, the sine of 30 is going to be the same thing. I'm sorry, I did it wrong. This one seems like sine. I've messed it. This one seems like sine 60. So anyway, so the sine of 30 is going to be the same thing of cosine of 60, right?
Yeah.
And the cosine of 30, it's going to be the same thing of sine of 60. So is that clear for you, of you?
Yeah, it's clear for me.
Yeah, okay. So this part, it seems like I'm not quite sure if you are still confusing or not.
No, I'm a bit better. So it's more like answering more questions. I will be better.
Yeah,